Today we will be going through the topic of vector embedding and vector searching techniques. We are now discussing the content that has been prepared from the deep learning AI course, and we will try to understand how fundamentally we create vector embeddings, create a collection, and embed data points into it. What are the different methods of then later searching this data points and stuff like this? We are using VV8 because this is what the course from Deep Learning AI, the RAC course discusses about, and we will discuss the same here. So to begin with, if you are dealing with creating a vector database, you start by creating a collection. The reason you create a collection is you can think it of in a traditional sense, like a database which has a table, and every table has a different name, and you can have multiple different tables in your database. So similarly, you can have multiple different collections in your vector database. Here, when you create this collection, we name this collection as article. So if you want to fetch information from this collection, you need to refer to this so that you can get the required information. You need an embedding model for creating the embeddings itself, and the same embedding model needs to be used when you perform the searches. Otherwise, you won't be able to find relevant information if you use a different embedding model for creating the collection and a different one for retrieving the information, because those data points of the embeddings will not make sense for a different embedding model because it will have a completely different architecture, it will have different semantic meaning. This will not result into any value when you return or when you use a different embedding model. Properties. What are the different properties? So there are different parts of the text. A text will not be just a blob of text. It might have some title, it might have some body, it might have some review, it might have some ratings. So for example, if you are going to index an IMDb website, so you will have the movie name, the title, the entire review of the movie, and then maybe you can also index some of the user reviews as an option, and you can index its rating. There are different ratings: user rating, critic rating. So all this might be useful for somebody who wants to choose which movie to go, and maybe somebody prefers a user rating rather than a critic rating. So you can choose to add all these details here so that when you fetch this information, you can specifically filter out by, let's say, user rating, and you don't want to prioritize the critic rating. So this might be useful here. Okay, so once you create a collection, you will need to add data points to it. What do I mean by data points? So since we are talking about IMDb ratings website, so data points will be these different movie reviews, right? So a new movie has come, Odyssey from Christopher Nolan, and you need to enter this Odyssey movie, which is the title of the movie, and you need to add the review of the as the body, let's say. So how do you do this? So, okay, you add this data point. Okay, if you start adding it from the scratch, you can do this with a big batch size because there are maybe millions of movies out there on IMDb. You cannot keep on adding one by one. This will take quite a lot of time. So you set a batch size, for example, 200, and then you can add these in batches so that you can quickly, yeah, append this into your whole collection. So when you add it as batches, it could be possible that some of those entries did not have the right data types, and this could result into some failures. So we also have some kind of a failure management system here. So if the errors exceed a certain limit, you will stop that batch because it's too much. You have to then ensure that the data is clean. It has the right metadata so that If the title is defined to be as text, but you get some kind of a number in the title, then this doesn't make sense to vectorize a number. You won't be able to receive the correct answer here. Okay. Moving on, let's try to understand what are the different search methodologies that you can perform in a vector database. So to begin with, you need to first decide which collection you need to query. So this is how you try to get this article collection that we created here in the first step. While creating the collection, we named it as articles. So we fetch that, and then when you have this object, you start this query. So query.nearText, this will by default perform a semantic search. So what is the query? The query is hotel capacity in downtown Vancouver. Okay, here we are talking about some other example. We are not talking about the IMDb example, but okay, let's say this query is it's a collection of different hotels and its reviews and stuff like this. Or I don't know, some based on seasons, there is this information related to which hotels have which capacity and stuff like this. So you put the query, this query will be converted into a semantic embedding again. So using the same embedding model that we used here, which was text to vec from OpenAI, the same embedding model will be used again to convert this query into a vector. And then you want to limit the returns to just two. You just want two returns. And you also want to get the metadata of the return, whereas you want to get the distance between the query vector and the return vector. You could use this information to further filter down. You just probably need, I mean, in case if the limit was 20, and then you want to filter the distance by the top 5 or top 10, and then you probably want to also do some re-ranking steps in the next step. So you can use this information. So this is the semantic query, but you don't have to restrict yourself to semantic query. The vector database also stores the raw text as payload or as metadata here, and you can also query those. One of the ways is by performing yeah, keyword search. So this would be a query Vancouver hotel capacity. And here the words Vancouver, hotel, and capacity, all three words will be searched as keyword search. And whichever articles have the highest number of matching words in their text or their body, that will be returned. So you can again set a limit of 3, but you don't have to do this separately. You can do both these keyword search and the semantic search that we did earlier using something called as hybrid search, where you can perform the same query and you can set the limits for what percentage of weightage you want to give to the vector search and what percentage you want to give it to the keyword search. So for example, setting alpha as 0.25 will give 25% weightage to the vectors return from the semantic search, and you are giving a higher weightage to the keyword search because you feel your query is very specific and you want these words. But let's say somebody writes a huge query which, yeah, the words are also not properly written. There are spelling mistakes and stuff like this that would mess up your keyword search. You don't want to perform an exhaustive keyword search with a lot of gibberish query. Um, there, giving a higher weightage to the vector search would make sense. I feel maybe just 25% of keyword and 75% of vector. Moving ahead, you can also filter by properties, wherein, as we thought earlier, for an IMDb movie search, some person prefers a user rating rather than a critic rating, or somebody else probably prefers a critic rating. So if you had fed these earlier initially as separate properties, then at this point you can actually filter by here. Okay, for in this example, instead of title you can say user rating, and then the search will be performed on all the properties in fact, but when the results are returned, the higher priority or the filtering will be done on user rating, and those documents will be returned to you based on the limit. So if the limit was again 20, all those returned values will have higher priority given to the filtered by property user rating. And this can ensure that you can customize your vector search based on the user's preference. And yeah, so these are the different ways you can perform searches in a vector database. And yeah, so if we have to look at the complete workflow here, you first configure the database, that is, you create a collection, you load the data, your individual data points, and then the final step would be the actual performing of searches, wherein you have semantic searching, you have keyword searching, you have hybrid searching as alternatives, and you can also search by specific properties that are present in the collection. So, hope this was informative. Thank you so much and have a nice day. Bye bye.